Hello everyone. Today we are excited to present our business intelligence project on predicting and analyzing malnutrition trends using machine learning. Malnutrition is a serious issue affecting millions of children worldwide. Many organizations, including governments and NGOs, need accurate data and prediction to take action. Our goal was to use machine learning to provide valuable insights into malnutrition trends. We had two main objectives. First, we wanted to predict future malnutrition rates using past data. This would help policymakers plan ahead and allocate resources where they were needed most. Second, we want to identify high-risk countries, the ones that are struggling the most with malnutrition. By doing this, organizations can prioritize aid efforts and focus on the most vulnerable regions. To achieve these objectives, we applied two machine learning models, a regression model to predict future trends and clustering model to group countries based on risk level. By the end of this presentation, you will see how our models provide actionable insights that could help fight malnutrition worldwide.
Next, I explain real-world problems and solutions. Malnutrition is a complex issue and different countries face different challenges. We identified two key problems that our project could help solve. The first problem, predicting malnutrition trends. Government and NGOs need to know how malnutrition rates will change in the future. If the rates are expected to rise, they need to take immediate action. If the rates are falling, they need to understand what's working and expand those efforts. To solve this, we use regression models to predict future malnutrition rates based on past trends. Our model helps government plan food distribution, healthcare programs, and funding well in advance. The second problem is identifying high-risk countries. Some countries suffer more from malnutrition due to poverty, lack of food, and poor health care. Instead of spreading aid equally, it makes sense to focus resources where they are needed most. To solve this, we use clustering models to group countries into low, medium, and high risk categories. This way, international organizations can prioritize an effort for the most vulnerable countries.
For this project, we used real-world dataset on malnutrition estimates. This dataset contains historical records of child malnutrition across different countries. Before we could use this data in our model, we had to clean up and pre-process it. Some values were missing, so we used a technique called median imputation to fill the gaps. We also converted categorical data like income classification into numerical values so that our machine learning algorithms could process them properly. There were many features in dataset, but we focused on the five most important ones. Here, it helps us track change in malnutrition over time. Income classification. It divides countries into different economic groups. Survey. It measures extreme weight loss in children. Underweight, a general indicator of malnutrition. U5 population. It represents the number of children under 5 who are most at risk. By focusing on these features, we are able to build modeling that give clear and meaningful insights.
We use two different machine learning models to address these problems. In the first model, we use random forest regression. which help us predict the future malnutrition rates. We choose this model because it handles the complex data well and provides the accurate predictions. One key insight from the model was malnutrition rates are expected to decline between 2025 and 2035, showing that investment and program are making impact. The second model we used was K-means clustering. The model grouped countries based on their malnutrition levels, economic status, and population. By clustering the countries into low, medium, and high risk groups, we can see which area need the most urgent attention. This helps NGOs and government target their necessary effectively. Both models provide the valuable insight that can be used in decision making.
Results and visualization. Now let's go over the results of our models and what they mean. For the regression model, we predicted malnutrition trends from 2025 to 2035. The results showed a gradual decline in malnutrition rates. This suggests that current intervention programs are working. Our line chart clearly shows this downward trend, which is useful for governments planning long-term strategies. For the clustering model, we divided countries into three groups: low, medium, and high risk. Our scatter plot visualization make it easier to see which countries fall into each category. This insight is useful for NGOs and policymakers who can now prioritize aid efforts based on actual data. These visualization make it earliest for decision makers to understand the situation at the glance. Its insight from our models can help fight and malnutrition more efficiency by ensuring that resources are allocated to the right places at the right time. Now, let's discuss some limitation and possible improvements to our project.
Limitation and errors. Although our module provide valuable insights, they do have some limitations. One of the biggest challenge was missing data. Some countries didn't have complete records, so we had to fill missing values using statistical methods. While this helps, it's not always 100% accurate. Another limitation is that our modules rely on historical trends. If there are sudden crises like economic collapse or natural disaster, our prediction may not account for it. For clustering module, the results depending on which feature we use. If we have chosen different factors and countries grouping might look different. This means there are some subjectively in how define high risk countries. Despite these challenges, our module provides strong insight that help with planning and decision making. In future, we could improve accuracy by using real-time data and exploring advanced deep learning methods. Overall, this project showed how machine learning can be used for real-world impact. Thank you.
Now, let's walk through our codes step by step to show how we build our machine learning models for predicting malnutrition trends and identify high-risk countries. First, we imported the dataset. It's some data pre-processing. This include removing unnecessary columns, handling missing values, and converting categorical data like income classification into numerical format so the model could process it. Next, we perform features selection, choosing the most important factors like income classification, serve wasting, underweight, and U5 population to predict stunting. We also standardize the data to improve model performance. Here we can see after some pre-processing steps, we begin to visualize the data we took with various charts. For our first model, we use random forest regression. For our first model, we use random forest regression to predict future malnutrition trends. We trained our model using past data, then made prediction for years 2025 to 2035. These results showed downward trends which are suggest progress in tackling malnutrition. For second model, we use k-means clustering to group clustering countries based on malnutrition risk level. The model clustered countries into low, medium, and high risk categories. It helped organizations prioritize intervention. Finally, we visualize our result using the graph for trends, prediction, scatter plot, or clustering. This helps decision making quickly understand the insight from our models. This project demonstration how machine learning can use to solve real-world problems, improving public health strategies.